Hello and welcome to the 14th video in this beginner series programming a tile puzzle game on the iPad using Cocos 2D. So in this video we'll start the first of two videos where we're actually going to be able to slide the tiles around the puzzle. So to start doing this we need to think about how we're going to do it, and the way it's going to work is we're going to store a square inside touch began in the place of this square from here. And assuming that the square's been okay and is not off the board, inside touch move, assuming that we're not then out of the board when we drag, we're going to keep updating what square we've dragged our finger to, and once this square is no longer equal to the square from, we know that we've dragged outside of our tile. We'll then look whether we can move our tile we started on to where our finger has moved to. And if we can, then we'll create a move action which will move the tile from the one square to the other, and if we can't, then we'll just cancel. So the first thing we'll need is at the top of gameplay layer.h is we'll need something to store our square that we're dragging in. So I've called it drag start square, and inside touch began we'll change this square from declaration here to the drag start square, which means also we'll drop the drag start square into here, and I'll change this log note here. The next thing I want to do is I want to go up to a function we've already created in a previous, and this function here called get square from point I'm going to rename to get tile square from point, because obviously it's only getting the square when there's a tile there, it's not doing it for the empty square. And now when we play the game we'll be dragging our finger hopefully into an empty square, so we need some way of knowing which location on the board that's on. So I've changed that name there, and you'll need also inside touch began to change the name, the function call name obviously here as well, so that things compile. So the first thing is to make a function that says can we move to a given square. So I'll put this up here just below out of board, and the declaration is going to look like this. So can we move from to square SQ from square from here. And the first thing we can say is if the board-oc, and this of course assumes that the square is actually from a 0 to 25, thank you very much IntelliSense, if the board-oc at the location of square 2, so square, the square we're moving to, is not equal to empty, then we can already safely return no, because we can only move our tile to an empty square. And now we have to think about the direction the tile's moving in, because the tiles aren't allowed to move diagonally. So if we think about our board, you remember our board is in 25, there are 25 entries like this, and I'll just put a quick comment under here where just putting a couple of rows in, we have 0, 1, 2, 3, 4, and then above we have 5, 6, 7, 8, 9, and so on. If we're pushing a tile in the upward direction, say from 2 to 7, we're going in a +5. If we go horizontal to the right, we're going in a +1. Down there's a -5, and left is a -1 direction. So bearing that in mind, in this function we're writing here, we can say that there's a difference between the square from and the square. And we'll say if this difference is less than 0, then let's make it a positive number. So we'll say diff multiplied by equals -1. Could also just use the abs function here, but I prefer to do it this way. And now we can say if our difference is not equal to 5 and our difference is not equal to 1, then we know that we've probably detected a diagonal move, and with our finger we've gone sort of diagonally up through the tile. So again we'll return no. Otherwise we know we're okay, and we can return yes, we can move to the square, from square F to square SQ. So that's the first important function we need. The next function we need is a way of knowing on the board from the 0 to 24 index where our finger has arrived, so which of these indexes arrived, so we can then move our tile there. And the way to do this is declare a function here, and I've got the declaration looking like so, where we take in a point, And the first thing we're going to do in this function is say that If the point that we're looking at is out of the border bounds, then we'll just return a -1. Otherwise, we just need to do some very simple maths just to find out which row and column our point is on. So I've got here x, so I take the x coordinate of the point that we've touched, take off the tile border and take off the bottom left x. So I'm effectively zeroing these. I also do exactly the same for the y. And I know that a tile occupies the width, and I'm going to add on the gap, because with a finger dragging to the tile 2, it doesn't really matter so much about the gaps in the middle, and it makes this a little bit easier. And then what I can say is I can use these x and y here to simply divide by this tile width to find out how many rows and columns along and up we actually are. Then the square itself, of course, is very easy then to get from the row and column. You simply multiply the row by 5 and add the column in this way. And I've got here just a quick note to the log just to check that things are going okay. So that's all we need from there. So we've got our two main functions for this video. One is to know can we move to a square, and the other one is to get the square that our finger is moving to. So once we've done that, we need to go back down into the touch moved function. And now, assuming that nothing's been cancelled and everything's running okay, we can say square2 equals, and then we'll call self, and we'll get square from point, get board square from point, which we've just written, and we'll use the touch location. So this is the square that our finger has moved to, and now we need to test whether it's empty and also a legal move. So the first thing I'm going to do actually is very quickly drop in a log statement again that I've prepared here just to log this. And now what we can say is if the drag start square is not equal to the square 2, so it means we've dragged our finger from the square we started on to another square, which means we might have a move. So I don't need this else here, sorry. We can then say if, and then we want to say self and can move to square, and remember we're moving to the square 2 from the square drag start square. So if we can move from one to the other, then at the moment, just for now, we'll do an ns log and we'll log legal. And what we'll do here in the next video is actually put in the animation to move the tile here. Otherwise, here we'll do the else I wanted to type, and we'll just log to the screen illegal. In this way. Okay, so that's it, and that should be all we actually need to do to be detecting whether moves are legal or not. So I'm just going to go to top left and run this on the simulator, and it says build failed. Why is that? Because I haven't typed an S for nslog. So I'll just run this again. And now it's running on the simulator, and if I just click around on tiles, it's found the tiles. And now if I click on, say, this tile which is 11 and then drag, you can see that it's noticed we've dragged from 11 to 12 and it's illegal. I drag from 11 to 12 and it's illegal. If I click just once on 23 but now drag to the space 24 which is empty, you can see it's seen immediately that this was legal. If I click on 19 and then click and drag, you can see it's also realized that this is legal. If I do this one here, which is 18, and drag left, it's illegal. If I try and drag 18 diagonally up here, it's also illegal from 18 to 24, so the diagonal's not moving it anyway. So good, we're now detecting our sliding moves. Now what we need to do in the next video is implement in the place of this legal statement the actual animating or moving of the tile to the empty square. So thanks very much for listening. Comments, questions, criticisms welcome as always on YouTube.